So in this video we'll be reviewing the test crosses, the partial and codominants, lethal genes, and the multiple alleles, which is a new concept which you'll have to write into your booklets. So anything you've missed this week, can you please make sure that you've also completed that into your booklets. So a test cross, this is just a review. It's used to determine if a group exhibiting a dominant trait is homozygous or heterozygous for that trait. And so we cross that individual whose genotype is unknown with an individual with a homozygote recessive genotype. So for the test cross, we're just going to look at the example that we looked at in class. So we've got the purple and white flowers. So on your left, just here, it's if the flower is a homozygote for that gene. And then in here, it's if it's a heterozygote for that gene. So if it's homozygote dominant, then you would end up with all 4 purple flowers in your F1 offspring, all heterozygote at the gene location, because you would have a dominant P allele and a recessive little p allele. On the other hand, if you had a heterozygote up at this flower here, which is the unknown, you would have 2 expressing the purple colouring and 2 expressing the white colouring, because you'd have a heterozygote at this and this flower, and you would have a homozygote recessive for this flower and this flower. So therefore the white phenotype would be expressed. Here the purple phenotype would be expressed because the purple is dominant over the white. So I just want you to look at these 2 flowers and think which one is incomplete and which one is codominance. So we've got incomplete on the left because it's an intermediate colour, and we've got codominance on the right because both are being expressed. Neither one is dominant over the other. So when we do incomplete and codominance, then we have a base letter, which is always the same. In this example, it's C. And then we have a superscript, which is here, which in this case is W. It doesn't have to always be C. It doesn't always have to be W. This is just an example. So if we look at partial dominance, we use a flower example. So here we're using C as the base letter, and R for red for the superscript, and here we're using the same base letter, which is C, and W for the superscript because we're using the white flower. So when we do this cross between a red and a white, we get the intermediate, which is the pink. That's your F1, your first generation after your parental generation, and they would be the heterozygote. Okay? So if we then go and cross 2 heterozygotes, which would be 2 pinks, set it out in your Punnett square, you'd have a red, you'd have a white, and you'd have 2 intermediates here and here. Which are heterozygote for the trait. So these 2 are intermediate, and this one is homozygote for red, this one is homozygote white. So here's your ratio, 1 to 2 to 1. In comparison, so this is when neither phenotype is dominant over the other, so the heterozygote expresses an intermediate phenotype. The key word here being intermediate. We'll then compare this to codominance, so this is what we learned in the last couple of lessons. So we had the white polar bear just here, we had the black polar bear just here, and both, when they breed, we put the big B here, big B here. Just make sure that we do it with the same base, which they haven't put here, so we'll just add in a B here. Ooh. And a B here. And then the W's and the B's here would be your superscript, just here and just here. and then we get both expressed. Alright, so that's when both is expressed, not just one. So you see the black and you see the white. So we'll move on to lethal genes. This is what we discussed in last class. That's when if you have something like a homozygote dominant, it is lethal, which means it can't live and it will die. So if in this case you've got a heterozygote with a heterozygote, and all these mice here can live because this one's heterozygote, heterozygote, and homozygote recessive, but this one here is showing that the homozygote dominant is lethal and the mouse can't live, so it dies. So multiple alleles, this is our new topic that we need to include into our work booklets. So multiple alleles is where you have 3 or more alleles of a gene that exists among the members of a population, and so there's usually a dominance hierarchy within these alleles. So if we think about it, it does not mean that the gene in a particular individual possesses more than 2 alleles. That's because you will get 1 allele from your mother and 1 from your father. So you can only have a maximum of 2 alleles. It's just that there's more options that you could have. So an individual can only have a maximum of those 2 alleles. So maternal, paternal, no matter how many alleles exist in the population. Okay, so that's a really important point when to remembering your multiple alleles. So for example, we have blood groups. We've got the blood group A, the blood group B, the blood group AB, and the blood group O. So that's what exists in the population. Here is the base letter, and then you put your superscript up the top. So in this case, when you're an A, your genotype is IA or IO, or you could be homozygote with IA, IA. For blood type B, you could be heterozygote, IB, IO, or you could be homozygote for IB, IB. If you're AB, then you're heterozygote, you've got an IA and an IB, and the O is recessive. So therefore you must have both as IOs. So in your dominance hierarchy, the recessive one is O. So just looking at these, this is just a table which you can have a look at later, and it explains if you have a parent of an O and an O, you're only ever going to get offspring with O because that is the recessive gene, allele on the gene. So here you can have a look at the table and see exactly what your options are, and try and do some Punnett squares looking at your parents and then checking with your offspring just to get the practice in. So for example, if you have AB, AB, you could have offspring with A, offspring with B, or a heterozygote with AB, compared with your top one where you can only get O because both parents were recessive for the trait. So we'll just do an example. Say we've got rabbits. There's 4 alleles that exist for the rabbit gene. So you've got the wild type, which is brown. We express it like this. The chinchilla, the Himalayan, and the albino. So the albino is the one that is the most recessive. So only if they have 2 C's, little c's, will that be expressed. So we've got wild type, which is dominant over everything, which is here, all the way down to the albino, which is recessive. We've got the black Himalayan one, which is dominant over C, and we've got the chinchilla, which is incompletely dominant. Remember what that word refers to, which is an intermediate, incompletely dominant over the Himalayan and the albino. So here we've got the example. So you've got the brown fur in the wild type, the black tipped white fur for the chinchilla, the Himalayan, which has white fur with black paws, nose, ears and tail, and the albino, which is all white. And you can see their genotypes up the top. So these ones are all homozygote. So we're just going to work through an example. So this one says, what types of offspring could be produced by a full colour rabbit that has a genotype of C plus CH? So this would be expressing the wild type brown that was bred with a Himalayan rabbit that was CHC. So this would be the albino one, which is recessive, and then you've got the Himalayan just here. So if we come down to the table, the Punnett square, you've got big C with a little plus, which is the wild type, then the CH, you've got the CH, CH, excuse my H, then we've got the big C, wild type, which is the brown one with the little c, and then you've got the little c, c, ch. So if we look at the offspring of the parents in the F1 generation in these 4 boxes down here, just circle them so you can see them. So we have 2 that would express full color, which is this one and this one, which is your wild type color because that is dominant over all of the others. You then have 2, which is this one and this one, which are chinchilla color, which is that incomplete dominant expression. All right, so you'd have a 2 to 2 phenotypic ratio for this example. If you look at the genotypic, so this is phenotypic, remember you should always include both your phenotypic and your genotypic ratios. Pheno, and we'll just put geno down here. We would have so that you've got your big C plus, little CH, that's 1. You've got your CH, C, CH, which is 1. And you've got your big C plus with your little c, which is 1. And then you've got your little c, C, CH. Okay, so it's a 1 to 1 to 1 to 1 ratio, and your phenotypic ratio is a 2 to 2. So have a go looking at those examples that we've just been on the last slide on if you mix 2 different rabbits together, what you might get, and then we'll review this on Monday. Thanks.